Okay, 2-5 deals with reasoning in algebra and geometry. So what we're starting here is our section on going through proofs. And with proofs, you always have to be able to justify every step. Some of them are simple steps, some of them are more difficult steps. So, addition property, we learned in algebra, once we add to one side, you have to add to the other. So anytime we have to do that, we call it addition property. Subtraction property, same thing. If we subtract from one side, we subtract from the other. Multiplication property, multiply one side, multiply the other. Division property, divide one side, divide the other. Reflexive, we use a lot when we have to come up with our numbers or our segments or angles that we have to add or subtract to each side or multiply and divide on each side. So reflexive is A equals A. Symmetric property, sometimes they're given as A equals B and we have to switch them, B equals A. So that is symmetric property. Transitive property we use a lot. If A equals B and B equals C, then A equals C. Substitution property, if A equals B, then B can be replaced with A in any expression. So sometimes you have to solve equations just like you do in algebra, and sometimes we use all those in just our proofs. Distributive property. The book likes to use distributive property when we add like terms. So they'll say if you had a 3x plus 2x, they would factor out the x and then have the 3 plus 2 and add it. So distributive property again can either go from taking a times b, add it to the a times c to get ab plus ac, or it can go backwards from this to factor it out. Same thing in subtraction. We can either multiply and distribute the a or factor out an a and rewrite it. Three other properties we use. Now our first ones we gave all in equals. With these we can also do them using our congruent symbol. So again, if you use equals, it's when you're talking about the actual measures of things. Congruence is when you are talking about the physical segments, lines, angles. So we can do reflexive in either line segments or angles, symmetric with line segments or angles, and transitives also with line segments and angles, all using the congruent sign. So where we use this the most is during proofs. And so we're starting to look at our drawings and go from there and write out all our steps. So in the drawing I have a line AC, a ray OM, and we have the two angles of 2x plus 30 and x. Those are the measures of the degrees. So you're given that angle AOM and angle MOC are a linear pair. So we're going to start looking at our drawing, our definition, linear pair, to know what to do. So in all of geometry, they'll give you a little bit of information. You have to come up with the conclusion. And the conclusion says find the value of x. So if we put this in a proof, we are doing a two-column proof where we have the statement and the reason. So angle, just to get you again ready for that idea, we explain it in 2-6. Angle AOM and angle MOC are a linear pair that was given to us. So knowing that, I can go, okay, I have the definition of linear pair that was given to me earlier, And a linear pair says that the two angles, AOM and MOC, are supplementary by the linear pair postulate. And then by definition of supplementary, I know that the two angles add together to equal 180. So now I can do substitution where my 2x plus 30 plus my MOC, which was x degrees, equals the 180 degrees. Okay, so this is where I disagree with the book. It always likes to use distributive property. I am fine with add like terms because we take 2x plus 1x is 3x. The book wants to take the 2x plus 1x, factor out the x, do the 2 plus 1 to get the 3x, and that's why they use distributive property. You can just say add like terms. And then the 30 is just brought down, finish out my equation. So now, to get from this step to this step, what did they do? Well, I had to get rid of the 30, so I would subtract 30 from both sides. So to get 3x equals 150, it's subtraction property of equality. To go from 3 times x equals 150 to x equals 50, I would have had to divide both sides by 3 to get x equals 50, so it's division property. So all they want you to do is go through a proof type statement and set it up and say all your reasons to it. So if you'll come get worksheet 2-5 from me, you can follow along with me and do all these steps along with me. All right, so hopefully you have the worksheet now. If we look at 0.25x plus 2x, the next step is 2.25x. So what have they done? They have combined like terms using distributive property. So you can just do combine like terms, or you can do distributive property, or a combination of both. To go from 2.25x plus 12 equals 39 to just 2.25x equals 27, they got rid of the 12 by subtraction, property of equality. To go from 2.25x equals 27 to 225x equals 2700, they went and multiplied both sides by 100, so it's multiplication property of equality. And then to go from 225x to single x, they divided both sides by 225, so division property of equality. So justifying each step is not that hard. So I'm going to let you go through. They have all the steps here for you in problem 2. They had the first two given to you, and you would just do the next 3. In this next problem 3, you're given KL is 3 of PM. And in the drawing, KL is 5x, PM is 2x minus 4. So they already gave us the distributive property. Substitution property. So all they did was replace KL with 5x and the PM with a 2x minus 4. So now we have the equation. I put down distributive property already because they went 3 times 2 gives me 6. 3 times the negative 4 gives me the negative 12. So now the next step, they get negative x equals negative 12. So what did they do? They had to subtract 6. But my other pen would work better. Subtract 6x from both sides. And that would give you negative x, so this would be subtraction property of equality. Then to go to negative x is negative 12. They divided both sides by negative 1, so division property of equality. So just everything that pops into your head of what you're doing from going from one step to the next, just write it down. So then we go through and we have some properties that we have to name. So if we have look and go xy equals tz, tz equals xy, they flip to the sides, so that is symmetric property that allows you to switch the sides. If you go to negative 2n plus 6 plus 4, to get the 4 plus, my brain just quit. So 4n plus 6 minus 2n. They added the like terms to get 2n plus 6. Again, the book will say it's distributive property. They also say associative property because you had to switch these two and then regroup them to associate. So we also switched them, which is transitive property also. And associative and distributive. So this one, when they just take 3 times x, write down the answer, 3 times 2, write down the answer, distributive property of equality. If we have angle A is congruent to angle B and angle B is congruent to angle C, and we get angle A is congruent to C, and that is your transitive property of equality. Congruency this time because it has congruent symbols. So that's all you're doing. We turn over to the other side. We are justifying each step in a 2-column proof. You start with being given that angle QWT and angle TWX are complementary. So you write down given, you can just put a G. Then they went from the words to write down what complementary angles mean, that the two angles add up to equal 90. So you know that's definition of complementary angles. Now QTW, they wrote 2x. Angle TWX is x plus 6, and if you look over here, they gave you that in the drawing. So you replace the angle with what it was equal to, so that is substitution. And 2x plus x became 3x, so that's combining like terms. Now we go 3x plus 6, and we just get 3x, so they did subtraction of 6x on both sides. Go from 3x to x, division. So again, each step is going to be laid out for you in your problem. The reasons in this one are also given to you on several of them. And then give problem 11 a try also. There is also homework to do in your homework on Math Excel for school. Have fun with it.